Hello everyone, I hope you're doing well. In this video, we'll be drawing directions from given Miller indices in hexagonal crystal system. Okay, it is a really tricky thing to do, and I must say, and one of my subscribers told me to upload that video, and they have given two sets of Miller indices to me. They were actually Miller bravais indices because we know that in HCP we have a 4-index system, and he asked me to draw these two directions in HCP. Alright, so in this video we'll be drawing these two directions, and in later videos we'll be doing some tricky problems in which we'll be having negative Miller indices and a combination of everything. Okay, so let's get started with these two directions. So first of all, I want you people to have a look on the method that I am gonna follow, and you can follow that method every time you are gonna draw the directions from given Miller indices. Okay, so the first thing that we have to do is to convert Miller bravais indices. The 4-index system is known as the Miller bravais indices. These are the Miller bravais indices. So you have to first convert these Miller bravais indices into Miller indices. 3-index system brackets, which is Miller indices. Okay, you have to make this conversion first. Okay, after converting these 4-digit Miller indices into 3-digit Miller indices, what you have to do next is to define the coordinate system, because once we have found the indices, we have to draw the HCP unit cell, and we'll define the coordinate system inside HCP. And after doing that, the vector, the direction has two main components in it. One is its head and the other is its tail. While drawing the directions from given Miller indices, the tail is always held at origin. So the tail is at origin always, and head is determined from these Miller indices that were derived from the actual direction which needs to be drawn. Okay, so the tail will be at origin and the head will be determined, the head coordinates will be determined from the Miller indices. Okay, we'll see how, and after that we'll join tail to head to get direction. Okay, so the direction will be drawn by connecting tail with the head with a straight line. Okay, that's it. That's a really simple method, and you'll see it is really easy the way I'm doing. Okay, so let's quickly get started with the first direction, which is 1120. First of all, what you have to do is to convert it into Miller indices. Okay, then we'll do the rest of the process. I'm gonna use H, K, I, and L symbols for these formula indices. Okay, and these are just symbols, and you can use your own. For example, in some books it's UVW, UVTW. It's UVTW. In other books it's HKIL formula bravais indices. Okay, if you are using this notation, I'll try my best to upload a separate video using this notation, because sometimes students get confused because they are already confused, and this mix match of notation makes them additionally more confused. So I'll be uploading a separate video using these notations, but in this video I'm using HKIL for Miller bravais indices. Okay, and here we can see that H will be equals to 1, K is equals to 1, I is equals to 2, and L is equals to 0. Okay, this is the first index shows H index, second shows K index, third shows I index, and the fourth shows L index. Okay, that is how I just named them, and this is all letting, and let the corresponding Miller indices are representing by corresponding their corresponding Miller indices are H prime, K prime, and L prime. Okay, since there are only 3 indices in Miller indices system. Okay, in Miller-Bravais indices we have 4 of them, and in Miller indices system we have 3 of them. So we need to know the conversion relation. So these are given by these H prime, K prime, and L prime are something that we need to know. Okay, as you know, the first step always is to convert Miller-Bravais indices into Miller indices. So that is what we are doing. We are finding out the value of H prime, K prime, and L prime for these Miller-Bravais indices. So H prime is equals to K prime. I'm gonna mention the general formula here that you can remember really easily, and it's really simple. H prime is equals to H minus I. K prime is equals to K minus I. L prime is equals to L. No difference. Okay, this is a really simple formula. You can remember it easily. So we know the value of H, I, K, and L. These are really simple. So let's plug these values right into this transformation equations. H is 1, I is 2. H is 1, I is 2. So 1 minus 2 is minus 1. K prime equals K minus 1. K is 1, I is 2. So 1 minus 2, it's minus 1. L prime equals L, no difference. So L equals 0. So L prime will be equal to 0 as well. So we have successfully calculated Miller indices. Okay, so the Miller indices or we can write them in brackets as well. H prime, K prime, L prime, that is equals to 1 bar, because it's negative, 1 bar and 0. We have successfully calculated or converted Miller-Bravais indices into Miller indices. Okay, this is a separate kind of question that occasionally comes in exam, that you are given with a Miller-Bravais indices for direction, convert them into Miller indices. Okay, this is the method that you can use. These are the equations that will help you to convert them. Now, these Miller indices will help us to find out the head coordinate of the direction. As I told you that in a direction there are 2 main components. One is its tail and the other is its head. So tail is always at origin, while the head is determined from the Miller indices. So we'll determine the head from these Miller indices. Let's find out the head coordinates from these Miller indices. So head coordinates are calculated as follows. Okay, the first index will give the coordinate for A1 axis, the second index will give the coordinate for A2 axis, and the third index gives the coordinate for the Z axis. Okay, if you don't know, then let me tell you that in hexagonal crystal system there are 4D coordinate system. One axis is A1, second axis is A2, third axis is A3, and the fourth axis is Z. Okay, while drawing the directions, we only consider the 3 of them because we are dealing with Miller indices here, not Miller-Bravais indices right now. There are 3 of the indices, so we'll have 3 coordinates, A1, A2, and Z. We'll ignore A3. We'll just imagine that A3 doesn't exist. Okay, that is the method that you have to follow. So because we have Miller indices, 3 of them are there, so we'll be considering A1, A2, and Z axis. Just like in 3D coordinate system, we have x-axis, y-axis, and z-axis. These are just names. Okay, these are just symbols. So we have named A1, A2, A3, and Z axis in HCP. So we will be considering 3 of them, A1, A2, and Z. I'll draw them. It will be clear later on, but I just want to do the mathematical part right here so that we can do the drawing part later on. Okay, so the first index will give you the A1 coordinate, second index will give you the A2 coordinate, and Z index will give you the Z coordinate. So what you have to do is, whenever it's given that you divide the LCM of the Miller indices, which are non-zero, obviously 0 is not taken in LCM process, and divide it with all of the indices, and the number you get are the coordinates. Okay, since it's 1 here, so dividing by 1 doesn't make any difference. That is why we'll be taking -1 as coordinate for A1 axis, -1. 1 bar means -1. Okay, so in 0 for here. Okay, if it would have been something else, for example, if it would have been 1 bar 2 0, for example, then the LCM of these indices is, one index is 1 and the second is 2, so LCM of 1 and 2 is 2 ones are 2, so LCM is 2. So we would have divided all of the indices by 2, and we would have got 1 by 2, -1 by 2, and 1 and 0. So these would have been the final coordinates for the head in the direction. But since we have all ones here, so LCM of 1 is 1 and dividing by 1 doesn't make any difference. That is why in this particular case, these are the final coordinates for the head, simply. Or the coordinates are the head coordinates for the direction, while the tail is at origin, simply for the direction. Now let's draw the HCP unit cell, and then we would draw these points and we'll get the direction. Okay, let's draw HCP here, HCP unit cell, and how I'm gonna draw is I'll first draw this line, okay, this sloped line like that, which consists of 2 lines. Okay, follow this rule to make a beautiful HCP unit cell. Okay, and then I'll draw the similar line into you can see that there are 2 blocks. It consists of 2 blocks, and this line also consists of 2 blocks. And from some distance, I'm making another one like that in 2 blocks, and then this. Okay, join these lines together. This is the roof plane. And next on, what I'm gonna do is I'll draw a line of 5 blocks that is greater in blocks than the one that contains that is inside it. For example, there are 1, 2, 3, and 4 blocks, so I'll be drawing a line, a vertical line from each of these 6 points, vertical lines of equal length that will be accompanying 5 blocks. Okay, so a vertical line from this line, 1 block, 2 block, 3 block, 4 block, and 5 block. Okay, similarly from this point downward, these are 5 blocks. Now from this point I'll be drawing the 5 blocks as well, so it's 1 block, 2 block, 3 block, 4 block, and 5 block. 1 block, 2 block, 3 block, 4 block, and 5 blocks. Okay, and from these 2 points are left, since they are properly below this point, so to ensure that this line and this line doesn't overlap, we'll make a line slightly sidewise. Okay, so I'll be making 1, 2, 3, 4, and 5 block. Similarly here, 1, 2, 3, 4, and 5 blocks. Now we'll join these lines together to make the complete HCP structure. This line, this vertical line will be joined with the vertical line of this point. Okay, because they are consecutive, so they'll be joined like that. This vertical line will be joined with this vertical line. I hope you are understanding the principle behind it. This vertical line of this corner will be joined with the vertical line of this corner, so these 2 lines will be joined together similarly like that, and here we go. This is the HCP unit cell, you can see. this centermost point is origin. That is the origin. And now let's draw the coordinate lines. You can see we have easily drawn the HCP structure, and that's really simple. This is positive A1 direction. This is positive A1 direction. Leaving this corner, this from origin to this point is positive A1 direction. Leaving this point corner untouched, the next corner in line will be taken as A2. And then leaving this corner untouched, this corner is A3, which will not be considered here, but you should know what it is. Okay, and from this point vertically upward is the z-axis, and this point is origin. This point at which all of the axis line touch each other is the origin. Now, one more thing, that since this is positive A1 axis, a line opposite to it touching this corner, going from this corner, is the negative A1 axis. This is negative A1 axis. Similarly, this is positive A2 axis. This will be the negative A2 axis. And this is positive A3 axis. This will be the negative A3 axis, but this is not relevant. We are going to consider A1, A2, and Z directions only. And we have to move only along these directions. We are not allowed to move along A3 directions. Okay, we'll avoid moving along A3 directions. We are not allowed to do so. Okay, only those motions will be taken which will be parallel to either A1 or A2 or Z direction. Okay, so this is the tail of our direction at origin. Now let's draw the head. Let's find out the head point, which will be at -1 for A1, -1 for A2, and Z is 0. Okay, and what does coordinates mean? Coordinates tells us the location of the point. Okay, like how much motions along A1, A2, and Z directions we have to move to reach that point. Okay, so they tells you the location. So let's start moving and we'll reach our point. Okay, so starting from origin, this is, we have to move -1 unit along A1 direction. 1 means, what does 1 mean? 1 means from one corner to the other corner of the unit cell. Origin is also taken as corner. Okay, origin is only a different corner that we are considering. So from starting from origin to the corner of the unit cell is taken as 1 unit, and since it's negative, so we'll move in negative A1 direction. So I'm starting from this point, we'll move 1 unit along negative A1 direction, which is this point. Now from this point onwards, what we have to do next, it is -1 along A2 direction as well. So we are here right now and we have to move -1 unit along negative A2 direction. So this is positive A2 direction and this is negative A2 direction, and this is also negative A2 direction. They are parallel to each other. So from this point onward, we have to move to the other corner of the unit cell along negative direction of A2, which is this, to the other corner of the unit cell. And we can see that this is the final head point. Okay, and this is origin, and this is the tail point, and this is the head point. So we'll join these 2 points together to get our direction, and this was really simple. This is the direction. Here we have the arrowhead that shows that this is the head. So you don't need to draw these opaque lines. It was just to show the trajectory, and this is the 1120 direction. Okay, this is 1120 direction in HCP. That was really simple, and you must be surprised that 1120 direction in HCP is actually parallel to A3 axis, and you can even confirm that 112 bar 0 direction is Actually, this direction is the negative A3 direction. Okay, this is 112 bar 0 direction. Okay, that's the interesting fact in HCP directions. That, yeah, I hope you got it. 1120 direction is actually parallel to A3 direction, but its Miller bravais indices are 1120, and for the negative A3 direction it's 112 bar 0. And let's do 1100 direction now. We have four indices here. Let's say the first index is represented by H, the second is K, the third is I, and the fourth is L. Okay, I'm using HKIL notation, and we can write it as this separately, like H is 1, H index is 1, K index is 1, I index is 0, and L index is 0 as well. Okay, and the first step, as I told you people, is to convert the Miller-Bravais indices into Miller indices. So we have to use the transformation equation to convert the Miller-Bravais indices into Miller indices for directions. And we know that here is the transformation equations. H prime, K prime, and L prime are given by H prime is equals to H minus I, K prime is equals to K minus I, L prime equals L. Okay, that is a really simple transformation equation. H prime, K prime, and L prime are the Miller indices. Okay, I'm using this notation. H is 1, I is 0. 1 minus 0 equals to 1. K is 1. 1 minus 0 is equals to 1. And L is 0. So we have 110 as the Miller indices. So H prime, K prime, L prime equals here 110. Okay. For the direction, tail is at origin, while head coordinates are determined by following method: H prime, K prime, and L prime. H prime will give us the A1 coordinate, K prime will give us the A2 coordinate, L prime will give us the Z coordinate. Okay, there'll be three coordinates. Since there are three indices, so there'll be three coordinates. A3 coordinate is neglected in this method. Okay, so A3 coordinates will not be considered. And to determine the coordinates, what we have to do is to divide the LCM of indices by each of the indices. Okay, and here we can find out the LCM of indices, non-zero indices. It's 1 and 1, and LCM of 1 is again 1, and dividing by 1 by each of these indices doesn't make any difference. That is why we'll have 1, 1, and 0 as the final coordinates for the head of the direction, while the tail of the direction will be at origin. Since we can see that direction is accompanied by two essential components, one is its tail and the other is its head. Joining the head by tail by a straight line gives you the direction. Tail is at origin, we know that. Where will be the head? Head will be determined from the Miller indices, and we have got it. It's 110. We have to move 1 unit along A1 direction, and from that point onward 1 unit along A2 direction, and then 0 unit along Z direction. We'll reach the head point. We'll connect the tail point with the head point to get the direction. Simple as that. So let's quickly draw the HCP unit cell, and then we'll draw this direction because we know the head coordinates now. Okay, let's draw HCP like that. I have shared you the method to draw it. I always tend to use different colored pencils to ensure that and this centermost point is origin. This is z-axis. And let's draw the coordinate system. Z-axis is already defined. This is positive a1 direction, leaving this point untouched. This is the positive a2 direction. This is the a3 direction. Okay, this is negative a2 direction. This is negative a1 direction. Okay, these were the necessary things to do. And the tail of direction is here at origin. Now head needs to be determined, where the head is located, and we can do it by using the head coordinates, which are 1 1 0. These are the coordinates. So a1, a2 and z. Starting from origin, we have to move 1 unit along a1 direction. Starting from origin, 1 unit along a1 direction means to the other corner of the unit cell along a1 direction. So it means from one corner to the other corner of the unit cell, motion is taken as 1, okay, along axis direction. So origin is also taken as corner. Okay, so starting from origin to the other corner of the unit cell, which is this point, so this is taken as 1 unit motion. So like that, we moved here. Now what next is we have to move 1 unit along a2 direction as well. From this point onwards, okay, from this point onwards, it's just like we have started our car and we moved 1 unit along a1 and we want to reach the head point. So for that purpose, we have to move from this point onward 1 unit along a2 direction, which means in positive a2 direction from one corner to the other corner of unit cell. So this is a2 direction and this is parallel to a2 direction. So from this point onward, we'll move 1 unit to the other corner of unit cell. This is the other corner, so this is taken as 1 unit motion. Okay, and from this point onward, no motion along z direction is needed because it's 0. 0 means no motion at all. So this is the final point. So this is the final point, and joining the tail point with the head point will give you the direction. So like that. Okay, this is the direction. This is 1100 direction. Okay, that was really simple, as you can see. And if you are confused that about motions, keep that in mind, that always when you are moving along axis directions from one corner of the unit cell to the other corner of the unit cell along the axis direction, which means this is actually the axis direction since it's parallel to a2. This is axis direction as well since it's parallel to a2, negative a2. From one corner to the other corner, this whole motion will be taken as 1. This motion is parallel to a1 direction, you can see. So from one corner to the other corner, motion will be taken as 1. Similarly, origin is also taken as point, as a corner in the unit cell. It will be treated the same. So if you're moving like that from this point to the other corner of the unit cell, it's taken as 1. To the next corner, it doesn't mean that there is another corner and this whole will be taken as 1. It will be taken as 2 because there is one corner motion which is 1, then from one corner to the other corner which will be taken as 2 as the whole motion. But other than that, for example, if you are moving from this point to this point, this will not be taken as 1. Okay, from this point to this one, because it is not parallel to either at a time. At a time, it should be parallel to only one axis. Okay, there should be no angles with other axis lines, and you can see that it is not parallel to any of the direction. Okay, so I hope you got the point, and I'll meet you in next video where we'll be doing other kinds of problems which will be a lot more trickier. And you can see this is the negative a3 direction. So we saw that 1 1 2 0 direction is parallel to a3 direction and 1 1 0 0 direction is parallel to negative a3 direction. And you must be wondering that I told you earlier that 1 1 2 bar 0 is parallel to a3 direction. So you will be surprised to know that 1 1 2 bar 0 is parallel to is parallel to 1100 direction. Okay, they are all representing the same direction. Okay, if you draw this, you'll find out that this direction is actually this direction again. Okay, um, Miller indices that you are gonna get from these Miller-Bravais indices is 330. If you find LCM of Miller indices, it's 3 3 3 ones are 3 ones are, it's 3. Dividing by LCM, it gives you 1 1 0, and this is what you have got for the head coordinates of this direction as well. And you'll draw, when you'll draw using these head coordinates, you'll get the same direction. So it's just like a family of directions that represent the same directions in HCP. Okay, so different Miller indices are possible for a given direction. Okay, you don't need to be confused. Okay, and that is it for this video. I'll meet you in next one. Till then, if you have any questions, you can ask me. And goodbye, take care.